I have to go a little old school and actually write on the screen today because I forgot my iPad at home as well because I'm just, falling apart everywhere. And so making sure that's up and running. All right. So looking at that graph on your page where we have Megan's stuff, Megan's Disney vacation here. We're given some information that Megan and her family are traveling from Nashville to Orlando on a Disney trip. The trip is 685 miles. They go 65 miles an hour on average. And so naturally, as one does, she made an equation because she's living her best life. It's a choice. It's a choice. Okay. So they give you this whole picture, which I was going to pull up, but my screen's being a jerk. So it looks something vaguely like that. Ta-da. I'm a fine artiste. So first things first, what is our independent variable? Yeah. So our independent is our hours traveled. Which means our dependent is what?
Distance.
The distance. An easy way to see that is that our x value was our hours and our y value is our distance. So if you have a graph, it's like a cheat code for independent dependent variable. So now we're going to start looking at some other pieces of our graphs and figuring out what those pieces themselves mean. So the first thing I want us to find is the x-intercept. Where is the x-intercept? It will have at least something zero.
Wait, what are we talking about for?
The x-intercept.
Oh, like just in general?
In this particular case, where is the x-intercept?
Disney.
Not Disney.
Wait, what, page 11, right?
Correct. Each page.
Oh, okay.
Where's our x-intercept? In general, it's where it crosses what? The x-axis. So our x-intercept is where our line crosses our x-axis. So it's going to be right there. What value is that?
10.5.
10.5-ish. So its value is about 10.5. 10.5 what? Hours. What happens at 10.5 hours? Hours until they get there. So that's what we say when we say, what does it mean? Put it in context. What's the value? And then just keep saying what until you get something that makes sense. 10.5 what? Hours. Okay, 10.5 hours what? Until they get there. So then let's do the same thing but for our y-intercept. Where's our y-intercept?
6.
Yeah, it's where it crosses our y-axis. So it's that guy up there. So it's 685. How do I know it's 685 and not like 670? Because they tell us that in the equation, right? And in the paragraph. So you don't have to just use one tool to find our information. We can bounce around. So 685 what?
Miles away.
Miles. Yeah. Miles away when? At the start. Or at time 0. Is another way of saying it. So it's 685 distance at hour 0. 10.5 hours at distance 0. So there's like little pieces that we can shortcut and make kind of weird sentences. Those of you that didn't have me last semester, I tend to view grammar as a construct and spelling as a suggestion. So if your thought gets into my brain, I do not care about the grammar. 685 miles away at time 0, that is a perfect answer. Grammatically, your English teacher would be very grumpy about it. Not an English teacher. Genuinely, I've cried out of shock when I won a spelling bee once. It's 4th grade. Oh, I don't get to change colors anymore. My computer's super grumpy about colors. Okay, so the next thing we're going to talk about is the slope. What is our slope? So if we were just counting boxes, I can see how you get that. But I don't want to count boxes. See if there might be another tool we can use to find it. Looking for a slope.
5 miles per hour.
Yeah. So we can look at our equation here. We're already done here. We have our distance, 685 minus 65h. The piece that's multiplied against the variable, this guy, that's our slope. So minus 65 is our slope. Whatever is with our variable, doesn't matter which side it's on. If you slope intercept, here they've got kind of weird where they've got intercept and then slope. And what does that 65 mean?
Subtract
Double zero.
every time from
It subtracts every time. Absolutely right. How about with our labels?
Travel an hour.
Travels per hour. How much distance, our y's, per hour? Miles per hour. It's their speed. All of those words would work for me. Our last piece we're going to do on this one is talk about our domain and range. It's been a hot second since we talked domain and range. What's that?
Just a copy of the homework.
It's in the thingy. Yep. No worries, babe. So what is our domain going to be? What x values can it be?
1 to 10.
As I say, good catch on a little piece there. I'm gonna be a little slightly more specific. So it can go as big as 10.5, right? That's my max. What's the smallest my x values can be here? 0. So the way we're gonna write it is that my x values can be between 10.5 and 0. Why can't I have just x be less than 10.5? Why can't my x be negative 2?
Because it doesn't go that far back.
Well, my graph doesn't go that far back, but could I, like, draw an arrow on here and keep going?
No.
Why not?
You could. But that's not the y. Or that would be the range, right?
Because we can't go negative time.
Oh.
I can't have negative 2 on my hours.
Okay.
Otherwise, it means I'm driving away from Disney and going back in time, which would be cool, but that's not how that works. How about our range? 685. So the biggest it can be is 685. And what's the smallest it can be? 0. So my y's are between 0 and 685. We are not going to wind up using domain and range a ton. Like, it's not going to be we're going to say this every single time. But it can show up every now and then, and so I wanted us to kind of talk through what the heck they mean again. Because it's been a while for most of us since we identified domain and range. They're not super complicated, but they're mildly annoying. Which is normal. Okay. Oh, I love it. I wasn't even paying attention to my stuff because I totally did give myself the graph here. Oh well, I did it this way. We're totally right. Okay, so that's page 11. That's all we needed to do on there. What you're going to do now is you're going to look at page 13. Page 12 is just like places you can write your opinions with your own time. And I want you to work with a neighbor. And you're going to find all those same things, but this time you have to make your own picture. They give you the equation, they give you the paragraph. You're going to draw the picture, you're going to find our x and y intercepts, we're going to figure out our slope. See what you got. When in doubt, pick points and substitute them in. So you can work with a neighbor, but we're going to take about 10 minutes. And I want you guys to try and do this yourself. Try and do this for 10 minutes, okay? Get all the way to the picture. And then we'll talk it through.
right here, I don't know, would you go down 5 and over 1
Would you?
on the ground?
Everybody just go down or go up?
Up.
And my next question is it gonna go,
It will go that way.
it's gonna go up. So what's it count by here?
That's 2,000.
So are we able to go up 1? Are we able to go over 1? So then we need to figure out some other values. Okay? How can we do this? Trixie.
Wait, I know what's up.
Yeah, it's a little tricksy. I'm sneaky. You deceptive heartless. Alright, I know most of us have gotten at least parts of it. How about what's our y-intercept? 18,000. So our 18,000, come on, Ben, there we go. That's our y-intercept. 18,000 what?
Cost after making 0 shirts.
Cost after making no shirts. Perfect answer. You can also say her initial cost, her startup's cost, the amount she spends to build the house, to build the room. What's our slope mean in the context? Even without a picture, what does the slope mean? First things first, what is the slope? 5. Positive 5. Positive 5 what? Dollars for each shirt. Dollars per shirt. It's a weird looking S, but my stylist decided to be a jerk. Oh, I forgot my iPad at home. How can I draw this picture? Can I just count up 5 over 1? No. Why not?
The numbers.
Because I'm Trixie. Yes. Because it's not counting by ones. If it was counting by ones, I could go up 5 over 1 and do it that way. I'm counting by 2,000s on my y-axis and 100s on my x-axis. So they don't even match that way. So I can't even scale it up and go up 5,000 over 1,000. So what can I do to find another value I can use here?
Find out how many 100 shirts cost.
Let's find out how much 100 shirts cost. So a way you can do that, that is not what I meant. There we go, different color. So we can take our equation and use substitution to substitute in a value. So we can figure out the cost using our equation, 18,000 plus 5 times, and you can do 100. Or 200, or 300, or 500, or 900. I recommend sticking with stuff on the graph. So how much does it cost for 100 shirts? What? Oh, 18,500. I thought you said 1845. Like, what'd you do? That's okay. You just gotta remember I'm old, and sometimes you gotta repeat yourself. I'm rapidly approaching 40. I'm more than twice your age. It counts.
You're right.
I am. Because you know what really, really hurt to say this semester? I graduated from here 20 years ago. 20. My 20th high school reunion is this year.
Ew.
I know. That kind of hurts. All right, let's find a few more points, because 2 points is good, but I'd like more. Maybe do a big jump. Do 400.
It's okay.
20,000.
Alright.
Yeah, you're exactly right. Spot some patterns here. Because 5 times 400 going to be 2,000, right? So 400, the 400 shirts cost 2,000, which puts our total up at 20,000. But you don't have to do it in your head. You can take our 18,000 plus 5 times 400 and just do it. We could come in and do 800. We could fill in any of the values in between. I happened to pick the 400 because I knew it was going to put us right on a nice tidy point, and it makes it way easier to draw lines. Because even like this, my screen does not let me use a straight edge. So we're gonna, that was terrible. We're gonna get it close enough. I recommend, since you were on paper, using a ruler or a straight edge of some sort. You have surfaces you can use. My screens are grumpy, and it won't let me. What's up?
It actually works.
What, using a straight edge?
Yeah. Because I never did it.
Oh my gosh, I know, right?
Yeah.
Yeah.
You're like so straight on this thing. Like I'm trying to line it up for her.
When you're doing, like, you're trying to line up and you're using something weird, a good way to do it is to put your pen on your dot and then line up your thing. That'll show you how far away you need to be, and that'll make it easier to draw the line. Because I know sometimes when you use weird ones, like the edge of a phone or the edge of a calculator, it's fine. I also back here have rulers, bunches and bunches. Like I've got lots, y'all. All right. So we found the slope. We graphed the slope. Oh, we're doing good on time. So that is not what I meant. Goofy ghost. All right. So what you're gonna do is you are actually going to go on the Canvas page. There's an activity that y'all were supposed to do on Friday that one person did. So y'all go try again. Just saying. So I will get the link onto the Today page as well. But if you click on the January 12 button that's right there on the, page, there's a link to a Desmos activity that's practicing this stuff. Other option, I will also go put it on Today's page as well, just so we can work on it. For my one person who actually did do it on Friday, you can just get started on the homework, because there's a homework assignment as well. Okay, the homework is, it'll be homework, section 4, homework 2, which I will insert the link into the daily page. I just didn't, because organization, woohoo. It's called graphing, homework, T4H2, graphing in context. There we go. I don't even remember what the questions are. We're also going to talk more about that kind of stuff tomorrow. So we're going to be writing, that's more writing in context. So that'll be really heavily related to what we're doing tomorrow. But for those of you that didn't do the Desmos assignment yesterday. Now's your time. Go do that. And yeah, that is actually homework for tomorrow. So don't worry about T4 homework 2. You can try it if you want to, but that's more based off what we're talking about tomorrow. Okay? So do the Desmos thing. The link is on today's page. It is also on the January 12th page, which is Friday. Is what we were supposed to do while I wasn't here. Okay, so you guys have time to work on that. Ask questions, go through things. Let me know.